Captured with a drone. All right. This image is showing you different variation of DTM values. Now let me change the color variation for us. If I'm going to use, okay, let me just take this one out. Um, all right, let's just leave it like this. All right. I don't want to alter this now. This is the boundary of a place. All right. Are we all together? This is the boundary of a place, and for this boundary, let's assume I'm using rows. Yes. This is the boundary of a place we are trying to capture. Alright, for this boundary, we are having we need a topography mapping for this area. When I mean topography, we are trying to know the level of the ground surface within that location. Alright, and this result here, this boundary is form of sorry, this one sorry, okay. This one is a form of polygon line or points. What is it? What do we have here? Is it a point line or polygon? Polygon, very good. Then what we have here is a raster data. Okay? This raster data, if I should zoom closely, you will understand why it is a raster data. I'm going to try and zoom closely as much as possible. You can see this box here is one pixel, is one cell. Alright? So this cell, if I should take my identification tool, identify tool, and I should click it on this pixel, and it's giving me a number of 73.31 for this dark place. If I should click here, okay, 73.2 and 73.3. Which one is higher? 73.3, right? So it's telling me that anyone with 73.3 here is painted as dark, is black. Let's just say 70% gray or 80% gray. If you have about 30% gray here, that's 73.09, and 72.7 is painted as light gray. Alright, so you can see where we pick the values from. Now let's look at something like this. We have three color variations here. Alright, so you see that for each pixels they are carrying figures, they are carrying information that helps you to understand what you have on the surface of where you are mapping. Alright, so now if I'm going to click on this figure, it's giving me 73.1, this one is 73.2, and this one is 73.3. Okay, so mere looking at it without clicking on it, it gives the reader an understanding that this place with darker or let's say 70% gray is having higher elevation. Okay, while this place with lighter let's say 30% or 50% gray or something like this is having this kind of color variation is lower compared to what we have here. The one that is lighter, you can see it here, 72.7 to 73.08, and we have 73.09 to 73.2. So what is the process of the elevation? Is it coming from up to down or down to up? Very good. You understand now? So the elevation is coming from up to down. So this information is giving you a lot of information why you should plan this area. You are planning for leveling or drainage planning and not you want to do water irrigation, stuff like that. It helps you to understand how to plan program. Once you do something like leveling, once you do it, once you come out, you know that okay, you have to pick from up here to level down. You understand? Once you do drainage, you know that water will not move from down to up. Then you are ready. Water will move from up to down. So in cases like this, you know that this kind of video, top place where we have here, you can trace this water down to this side. You know that the peak of its elevation is here, the lowest is around here. Definitely water will accumulate more within this area. Do you understand? So this information gives you an understanding of what the topography looks like without you even having to look at each numbers of pixels around there. Then you can go by having a contour. A contour, you can segment your contour to maybe in pixel 10 centimeter interval, thereby you have different contour length of this area to give you information about that location. Alright, so all of this is just to give you information about the topography within this environment. Alright, I hope you understand what raster is and what vector is. Alright, so now the next thing we'll be looking at is just a minute. Maybe I should just leave the slide like this. Alright, the next thing we'll be looking at now is tools for capturing GIS. One of the tools we have here is sanitizers. Have anybody seen sanitizers? Something like the kind of better body. Who still use it? You have GPS. But what you're making use of GPS is practical section. We have Android GPS, which is having an accuracy of less than 5 meters, 3 meters, Android GPS. We have some sophisticated Android GPS that have accuracy of up to centimeters. Right? But differential GPS are always recognized to certificated people. That's how thereby you want to estimate the exact boundary of you want to estimate the exact boundary, you want to do what use differential GPS. Alright? Then total sensor is also one of the tools that have been used, that is also used in and now we have mobile mobile photography and many of them. And GIS software, there are current GIS software that let me show you something like if we have ArcMap, you can add a base map here. Alright. The base map you add on ArcMap is related to other open source um, platform like Google Earth, OpenStreetMap, majorly OpenStreetMap, right? So it enables you to overlay a base map while you are working, and if you are not sure of the location of the place, alright, let me try opening another map. Maybe because the loading this is too much. Alright, so once you have a base map, you can easily pick points. Just open a blank map. Okay, this is alright. I'll just use Google Earth in case of ArcMap and explain what I want to explain to you. Alright. We have a software like Google Earth, or you have a software like ArcGIS Pro or ArcGIS Online, you can be able to pick coordinates in any place on the world that you are familiar with. Alright, you can pick coordinates anywhere. Alright, so I'm familiar with Ikeja. This is Ikeja here, and I will try as much as possible to locate where we are. We are somewhere around, somewhere close to ShopRite. Okay, this is ShopRite. The bus stop before ShopRite, that is this, right? Okay, bus stop before ShopRite is this. Okay, okay, this is Geoinfotech here now. Alright. So now if I should click on this tool, By clicking on this tool, let me see if I have the coordinates here. Okay. The best way you can get coordinates for this, just click on your pin, add place mark. Once you click on it, drag this place mark here. As you are dragging the place mark, take note of the coordinates as it's changing. Alright. So if I should drag my place mark on Geoinfotech here, this gives you the coordinates of that location. Alright. But know that coordinates, or let's say getting special data, one of the most important things, as I'm getting my coordinates for this location, it's giving me an accuracy of less than 5 meters. 5 meters in the sense that with a radius of 5 meters around this point, my coordinate is correct. That means this coordinate that you are seeing here, if I should plot it on maybe with an handheld GPS or differential GPS, it will give you coordinates maybe within somewhere around there, right? It will not be exactly this point. Let me give you an example again. If I want to take the edge of this building, that's this edge, all right? They are trying to establish the edge of this building. If I should pick these coordinates here and I send it to a colleague of mine using coordinate system of the regions 1984, he's going to get the exact location but not exactly this boundary. It might be somewhere here, 5 meter radius around it. Okay, when I mean 5 meter radius is that if you're standing at this point, you can calculate 5 meter radius around you. So this point might not be exactly here, it might be down around right? Might be somewhere around there. So that's the issue we have with coordinate accuracy or data accuracy. So if you are doing a project with cadastral or whatever project you are working on, it determines the type of tool you use for that project. Okay, for example, you are trying to you are building an cadastral information system for an estate. All right, you're building a cadastral information system for an estate, and one of the key information you have to get for that estate is to establish the perimeter and the area size of each building or each plot. And if Sister Janet says that my plot is 25 meter, 250 by 250, or let's say it's 250 square meter, and they call it one plot, and Mr. Joseph says that his own plot is 257 square meter, you know there will be issues. You understand? Or let me give you another example. If I'm trying to if I get a plot of land and I want to build my own house to my taste, and you call your surveyor to come and do your drainage for your house, and you see that the drainage is starting from Sister Juliet's house, you know there will be issue. Mr. Julius will say that why will you have to start, and you start saying that this is where the coordinates started from. You understand? The coordinates will be having issue like that if they pick information like that with the handheld GPS or mobile device, or they use Google Earth to pick information like that. They will be having accuracy issues like 5 meter or 3 meter. But if you use a GPS like differential GPS, whereby the accuracy is about 0.01 millimeter or centimeter, you know that exactly where you pick that coordinate will be the location of that coordinate. Do you understand? I don't know if you are getting me. All right. Please, if you have any question, you can just drop me back, and then I'll try as much as possible to rephrase. All right. So now, what I'm trying to tell you is that whatever project you are working on, let's say the whole of Nigeria, the whole of Lagos, you want to do the analysis, and you want to see sound or sound where there is flow. You are doing analysis, you are doing it. Just for example, we have You can hear me if rain should fall and the entry can evaluate this exercise. Both of you will be having the same level. You understand? So what I'm trying to say now is that if you are trying to pick coordinates of dump sites, waste dump sites, an example, you just want to show a sample, you want to reference it on a map, that this is the location of a dump site. You can use Google Earth, you can use your Android GPS. It's not going to be exactly the location, but you are given a reference that is within this area. Do you understand? I hope you get that now. So back to tools for capturing GIS data. We have software like Survey 123, GIS, graphs, but these software are not recommended on certain projects. They are only recommended for few projects that also require high accuracy. Yes, that's just what I'm trying to explain. Now we have other GIS out there and we have tools like GPS. The reason why we use GPS is that when we are capturing a drone, then we want to apply it to the differential GPS. Now what is it? But drones with GPS help you to tag your images. When I mean geotagging of images is having drone images or images with coordinates. Let me show you an example of a drone image that has coordinates within it. All right. Trying to remember which one worked with recently. Okay, let's just use something like this. Okay, let's just use this one. For example, now we have a drone image. This is an example of a place that was captured with a drone, right? Just an example, all right? So if I should right click on this image and I should open the properties of this image, if I should go to details and I scroll down, you'll be having coordinates of latitude and longitude and altitude. Do you understand? So these coordinates are the geotag. Means that as a tag coordinates. Geo is just a classification. Right? Alright, so you all understand this now. Alright, now let me explain to you where you can get open source. So you can get data from GIS. You can also get from audio data from you can get from GIS. You can get from OpenStreetMap. OpenStreetMap is one of the you can get from NASA, you can get from so places like this place so you can get really map. A lot of people don't know how to create map. A lot of people don't know how to yeah, every supports open source data for PLC, support stuff like that. Anything data, you can download it and natural language data. GSGS is commonly used for raster data. Majorly raster data like EM, like that, and things like that. Okay. So now we have, sorry, we have open topography, support line and DN, population coverage estimation. What is the time when you say it's not all software that supports all programs. For example, now, I open Google Earth. Google Earth supports the use of, I think the current one supports the use of shapefile, KML, blah 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 like that. I don't know if it supports GeoJSON. Okay, this one. Okay, when you're trying to build a mobile app or web app, you will definitely use this is somewhere. If you are trying to work with, you are trying to build web application and also support you have to support shapefile, and you have to convert that environment. So now, this is what most GIS, what they know that Akma will support, and they know that you can convert from Akma to PLL. You use Akma environment to convert to PLL by government support. So let's say, for example, you pick your coordinates an handheld GPS. This is an handheld GPS, okay? You pick your coordinate with an handheld GPS like this one. This one is commonly used. We have other devices that installed for sale. This is an handheld GPS. So if you pick your coordinate with an handheld GPS, if you send this file to your phone by your phone, you have to use an environment that supports this file, which is the GPS file. The extension of the GPS file is GPS. Okay? The extension of this GPS file is GPS. Right? GPS. That's the extension. So you know that I can support GPS file, but Google Earth does not support GPS file. Then you know that since Atma supports GPS file, and it also enables you to convert the file to Google Earth KML file. So what you do is you import the file using Atma, you convert it in Atma to KML, then open it in Google Earth, and then now you have a lot of apps like Astro apps, KML. So this is not as GPS file is not supported with your phone. So you put it inside Aqua, then convert it from Aqua to PLL, then send the PLL file to your phone. So there is a process. So it depends. For example, now there is this issue that always comes between surveyors and GIS. One of the issues is AutoCAD. I don't know if everybody has seen that. It's AutoCAD. Okay, now, the AutoCAD comes like this. So the surveyor will say, I want to apply the the GIS analyst will say, I want to apply the shape. So there are these problems. So whatever file comes first, what you just have to do is find an environment of that. If you have to apply the PLL, you have to apply it for that PLL. But so we are not familiar with PLL, some of them are familiar with PLL, and some of them are familiar with PLL. And they are the GIS analysts. You know that the surveyor only needs to put the PLL and the AutoCAD. So So you convert the file from KML to SHP, then from SHP to ONSTAR. You understand? So that's the idea. So it's just all about conversion. It's very important that we have a session that we do conversion different formats. You have to do that. And it's an ACMAP as well. Yes, sir. Google Map is the web app. Google Lens is the software. You understand? Google Map is the web app. Google Lens is the software. All right. So, does anybody have any question with this open source platform? Do you have any question, please? All right. Then we'll move to the practical section. In this section, we'll be learning how to capture data with and how to integrate GIS data, how to format GIS data from GIS files, how to use your GIS software, and lastly, how to it's just your coding is just grammar. Right? So your coding is just about giving or replacing a coordinate. Right? You know when I open Google Maps, it's not showing you that you lost the coordinate here. But somebody told me you take that place and rename that place from the coordinate to your name. So if you come out Geoinfotech, it will bring the well, we need to start the coordinate. Alright? Let's just see that, for example, now if you are giving a place like an address. Then if you type an address so at that time, so when people say geocoding, the first thing that is you use the name of the place to start your so you also get coordinates of the place. And either you to since you don't know the coordinates you have, let's start with let's do a kind of translation to that. Yeah, I think we have it in ArcMap. Let's see if I have. Let me see. Alright, let me use this one as an example. Alright. So on this map, I don't know the coordinates of Lagos Island. I don't know the coordinates of Lagos Paro. So whatever name that has been registered is what you can only get. If you do not register a name there, you won't get the coordinates of that place. Alright. So to access this, you can just go to your find tool here. You see this find. Once you click on it, you have to select ArcGIS World Geocoding Service. If the other geocoding service you can have there, fine, but ArcGIS what you coding service. So whatever name that has been saved there is what you will get, right? So if I type Lagos State, for example, it will give me name of location for Lagos State. So if I should click on it, it will take me to the location of where Lagos State is. So it's giving me the location as that, alright. So if I should put my cursor here, I'm having coordinates of 3.9. You can see down right, bottom right. You can see something like this, 3.9, blah blah blah, like that. So let me just change the figure to something else. Let's use decimal degrees. So I want everybody to write it down for me. The coordinates for Lagos State. So it's pointing somewhere here. Okay, wait, sorry. Let me get just like this. Still the same thing. Okay, let's just pick Lagos Island. I'm trying to change the. Alright. So we are picking Lagos Island. That's Lagos Island here. So I'm going to establish a point there, just a rough sketch. Right? As this, right? I'm picking Lagos Island as this. Okay? Let me just convert this to. Um, okay. So, right. Let me see. Alright. Alright, so our Lagos Island is within here. Alright, what coordinate do we have there? So I'm going to bring up the shapefile for Lagos State so that at least it'll be easier for us to understand. Uh, so what we are finding is Lagos Island, right? So you can see where it's pointing to. Alright. It's telling me Lagos Island is somewhere here. Alright. So we're only getting this just with the help of the name. Right? Just with the help of the name. That's the idea. Right? So in cases whereby you don't know the coordinates, but you only know the name of a place, and the name has been registered somewhere like Google Map is global. You can easily and Google open street map. So you can just search for the name of the place. And if you search for the name of the place, probably you want to send the coordinates to an environment that they only understand coordinates. Do you get? They only understand coordinates. Let's say, for example, now these coordinates we are having here now is 3.39 and 6.45. So if we open 3.39 in Google Earth, I think Google Earth usually starts with latitude. So it's 6 point what? 6.45 and 3.39. 6.445 and 3.39. So 6.45 to 3.39 is that is going to Lagos Island. You understand? So the same way, if you type this on Google Map, um, if you type this on Google Map and you are trying to locate the coordinates of that same, just with the coordinates, what you just do is you type it starting with latitude. That's 6.45, right? 6.45 and 3.39. 6.45, 3.39 is taking you to Lagos Island. Okay. It just give you a reference point on where Lagos Island is. You understand? So this can be very can be used in military, all these military purposes in case they are trying to. This is what they do in this. Send a spy. Send a spy to the enemy to go and show the bomb exactly where their machineries are, their arsenals are. So just get the coordinates of that place around the room. Send the coordinates to the person airport. Not the person is flying airport, just send the bomb exactly that coordinate. And they have the kind of way of determining the movement and something like that. So let's not go to that part. But you understand what geocoding is all about, right? So another name for geocoding now, in case you have an address of a place, there are some software they just support, they call it geocode. You just put the address of a place in Excel. I promise you. Based on the address. Once you import the Excel inside the software, just generate the coordinates for all these. Between tagging and geocoding is that the tagging works with multimedia. Tagging puts content inside it. So you are putting the content inside an image. You have like the example I said, you have the content inside. And so you notice that your camera setting where it tells you to information. Sometimes it's like you try. So once you enable location like that, if you add so any picture you take, they have the location of that picture stored inside. So sometimes when you have some other device like that, if you put through and you see something like a form shows you the image of that something like that. So when in some cases when you are snapping the Google just that take picture with your phone, you see on that Google map of that place, you see those pictures of those when you are scrolling up attached to that application. So the difference is just that your body is code that's the way or the order something and address. They are replacing your address. Why do you have this images? Do you have any question before we move to the next section?